to calculate the kinetic energy, then you calculate change in kinetic energy, and which is equal to the work done by the work energy theorem. So this is how we can use it out. Next question is it's from the center of mass. So the first question is the position vector of center of mass. So it is integration mi/ri upon integration sigma mi. Sorry, integration is not there. It's a discrete particle system. So this is how to find the position vector of a system of particles whose masses are mi corresponding to the ith particle, and whose position vector with respect to a reference O is vector ri. So if we calculate the position vector of this system, we name it as RCM, and that is equal to sigma mi ri by sigma mi. This is the definition of the position vector center of mass. Next is the velocity of center of mass. So just differentiate it, you get sigma mi vi upon sigma mi. So just imagine that there are n particles in a system, and each one is having masses m1, m2 up to mn, and having velocities v1, v2 up to vn. There is a random distribution of velocities. So you just find the summation mi vi, take the limit from I is equal to 1 to n, and divide it by sigma of mi. So you can calculate the velocity of center of mass of the system. Next is we need to find expression for the acceleration of center of mass. It is also equal to you just differentiate velocity of center of mass. So we have the expression acceleration center of mass is equal to sigma mi ai, I is equal to 1 to n divided by sigma mi. So you can see the symmetry in all the three forms. You just use symmetry and replace RV and A. So using the same concept, same formula, you can find the position of center of mass, the velocity of center of mass, or the acceleration of the center of mass of a system of discrete particle systems. If the bodies are continuous, you need to use integration instead of the sigma thing. So this is how you can calculate these things out. Next is there is a one important question that if external force on a system is zero, then linear momentum remains constant. This is called the law of conservation of linear momentum for a system. So this is how we can explain the very basic things related to this topic. So the topic under consideration is work and center of mass and its various applications, then potential energy and the work done by the force. So we have covered these topics. It's just a checking mechanism of how you are studying. So if you are able to cope up with more than 80% content, you are able to retain those things, that means you are working finely. But if you are not able to retain, that means you need to check your process of preparation. You need to orient more along exam, more along problem solving skills. But the final form should be that you should be able to answer questions quickly, as you should match up with the speed which I am making up. Only then you can think that you can do good in exam, you can crack the exam. So just stay optimized, and if you have any doubt, you can ask in the doubt section. Thank you and have a nice day.